While they're setting up the presentation, I'm going to introduce not myself, but Flash channels. First of all, you'll see this nice design. This is not mine. This is from Sabri Goldberg, the Iota Foundation designer. And you will see a few of his designs throughout the presentation. Since I'm not a designer, I'm an engineer. So that aside, let's just focus on Flash channels. This is why we are all here. So what is it? Once you heard about Flash channels, you would say, okay, it's something like quick, but the main thing is it's a bidirectional off-tangle payment channel. So let's go step by step. We first have a bidirectional because you can have payments from one party to the other, and then from the second one to the first one. But also not only two parties, but any amount we want. So that's something that's different from other payment channels, whether you also have off-tangle transactions. So what does it mean? So we get transactions on Tangle, like MAM is using, or whatever traditional transactions you want. You can also send value transaction there, and you can sell zero value transactions. So what's the issue here, or why do we want this type of channels? So you get instant transactions, you get a high throughput, and without all this overhead, you get fast transactions. But also, keep in mind that while we are working with Iota, everything is feeless. So you don't pay for any transactions, either on Tangle or off Tangle. You do have to do proof of work for on Tangle transactions, but the good thing is Flash channels only need an opening transaction and a closing transaction, which I will get into in a little bit. So why instant? So instant transactions are an easier way for transacting between machines. That's something Iota always is looking forward to, and also people to machines and machines to people, or even people altogether. So only two transactions, one for opening, one for closing, is needed to be on Tangle. The rest is done off Tangle, meaning it goes from each party without going through Tangle. And that sounds a bit complicated, but let's just hold that thought. And we have a high throughput. Why is that? Because the high frequency you can use for transactions is done because there's no need for attaching to the Tangle each of the transactions. So I'm going a bit quick just because we don't have that many time. So fast, this is what I want to get to. Whenever you want to say you are transacting or you're translating money, you are sending money from one place to the other, there's always the issue about trusting the other party or knowing the money got there and it's confirmed by the network. So there's a few ways you can do this. You can wait for the transaction to be confirmed by the network, but that will give you a lot of time and delay for the transactions. And figure if you want to use this as something that a machine can send money to another machine, they don't want to wait. They don't want to do this quick, and because most of the time these transactions are done over a set amount of time, but a lot of transactions are done in that small amount of time. So transactions are as fast as the connection between the parties. So if two machines are connected via Wi-Fi, then the speed between those two machines is going to dictate the transaction speed. You don't need to wait for the Tangle to confirm the transactions. You don't need to wait for other transactions from the network to confirm yours. You just need to wait for the first transaction to confirm to the network by other transactions on the Tangle. And then you can start using this first one as a base, and then keep going through all the transactions you want, back and forth, and then the last one is the one that will get all these transactions, bundle them in a single transaction on Tangle, and that will give you the confirmation that everything was done, and that's something that there's no need for in the middle. And of course, it's a Tangle, it's Iota, so it's feeless. So how does this work in a way that we can assure it's working? Because we are not using the tangle to confirm any transactions. So the main thing here is one more of a technical way of verify everything's working, and the other one is a way for the users to know it's working, or maybe to force the users, either machines or humans, that's working. So one is multi-signature addresses. That means one transaction, one address that's controlled by more than one user. That's something that other cryptocurrencies have. There's nothing new about here, but the use of this particular feature is key on making this work. And the other one is economic incentives. I know Sergey already talked about a bit, but the thing here is this is key to make this whole idea work. And I'm going to tell you why in a sec. So multi-signatures are deposited on a single address that's controlled by all the parties involved in the Flash channel. So when you set up a channel, you first say, all right, I'm going to transact with how many other parties. Normally, most of the examples you get around are from one party to another. One is like maybe a business, and the other one is a buyer, and you most likely get the one direction transaction, but you can't do any type of transactions you want. So all parties, in this case, need to agree to take money out of this address. So that's the basics of the channels. Each channel has a single deposit address where all the parties deposit their first amount of stake, which I'll talk about in a minute. And then they all need to agree on what to do with it. There's no way one party can say, okay, I want to take everything that's on balance and keep it. The only way for him or her to do that is to make sure the other parties are okay with it. And the consensus here is more about an economic incentive in a way, because each party has the equal incentive to make sure they want the same thing. But here's the catch. There's no need for all the parties to stake the same amount. One can use, for instance, I'm going to give you some examples for you to get ahead of it. So if you want to go to the gas station and you want to pay for gas, or maybe energy if you have an electric car or an EVC, so there's no need for you to prepay or pre-authorize a set amount of money for then the company selling you the energy can take from. It's only about of the company having to stake the same amount of you, so both parties have the same stake on the channel, meaning both have the same incentive to make sure the whole transaction goes smoothly and no one gets scammed or in a state where they don't want to be. So each time a transaction goes to the other side, both sides need to accept it and sign the transaction with the first multi-signature transaction. So a few use cases of M of N, meaning maybe you have 3 parties, but only 2 need to be on the same page, or just 2 need to come to a consensus, meaning there should be only one third party that's trusted by the other 2, maybe an escrow or an advisor or someone trusted that can settle any issues or maybe disputes. So one of the main features of economic incentives applied to Flash channels is the thing that each party is encouraged to take the latest state of the channel, because it gives him or her the most beneficial outcome. If you want to attach or exit the channel prematurely, you will stay in a way where you're not as good, or you are going to lose money or Iota tokens if you do so. So this is the main way for you to make sure the other party is not going to scam you, because it's not useful for them. So this was pretty much the main non-technical explanation of it. I know it might be a bit confusing at first, but let's get some technical stuff in, and you will get a few more nice designs from Sabri, not myself. So when I say Flash channel, it's more of a concept, not an implementation. So you get the Flash network tree, and I'm going to get to that in a sec. And then you have the bundles and the tangle. Bundles and tangle are something that you already know about. It's what we use to make transactions on Tangle. But then you got a binary tree, binary because it has always 2 leaves out from each node. And then this will give you a way for you to reduce the transactions amount that you need to attach to the Tangle. And also a way for you to keep track of what you're doing, transaction after transaction. So nodes in this graph are the bundles, and then the leaves are 16, 17 to 31 are the transaction of the channel. So each time you need to make a new transaction, you need to take one of the leaves of the node, of the tree, and then you will use each of those consecutively. When you get to the last one, you are out of transactions and this channel should be closed. What you can do is you can chain different channels, so you always have more available. And that's something that is also free and encouraged because there's no there's no fee for adding transactions to a channel, and there's no fee for attaching a new channel to an existing one if you want to keep going. So a few more technical stuff about this that I know it's useful for developers is that the transaction maximum is set by the depth of the tree. In this case, you get 16 transactions from 16 to 31. So if you want to have this, the depth of the tree should be calculated backwards from the maximum amount of transaction you want. So in this case, you go base 2 logarithm of the maximum amount of transactions that you want. Some of you are looking at me and saying that what's wrong with him. But anyway, so let's go to opening a channel. So whenever you want to open a channel, there are a few steps that you need to get to. First, you need to send some tokens to a channel. But before you do that, you have to specify what the channel is about. If you want to use this for payments on electricity, you want to stream electricity for you on pay as you stream it. A way for that to be is you don't want to set a maximum transactions because you know how much you want to get. So instead, you set up a small channel and then you chain it. Of course, there's always a maximum transactions, but as long as you can chain them, there's no issue there. So the maximum transaction is something you set up at the depth, as I said before. Then you set an initial transaction that generates all the, let me show you. All the nodes from the tree are generated from 16 to 1 are generated from the first transaction, and that sets up the bundle. And the first transaction is the one that's attached to the tangle. And once that transaction is set up, you can keep adding more transfers and such. So at the same time you say, okay, I want to start a channel, you need to deposit some with the first transaction, all your stake in the channel. Your stake's going to be all the transactionable amount you will be able to use throughout the channel. You won't be able to transact more than the first deposit, and you will be able to get change back if you don't use it all of it. So after the confirmation, the channel is ready to use, and all the money is set on the multi-signature address, meaning at this point of time, all the parties have the same stake on the channel, meaning every channel every user deposited the same amount on the first transaction. So at this point, the best outcome is for them to attach this state, getting the same as they deposited in the first place. So let's go to Sabre's design again. We get, I don't think you can see the lines. Can you see the lines? Okay, perfect. So in this case, we have Iwa and Yannick, 2 users that want to transact. So the first thing they need to do is open the channel. So what they are going to need to do is generate initial digits. This is really technical, but the main thing you need to understand about it is that every time you sign a transaction from the Trinity wallet, you want to send somewhere, or maybe send to an exchange or pay something online with Iota, you need to sign for that transaction. So what we are going to do is preset a few of these signatures that we can use later for verifying that I am or whoever is the one that's signing. So whatever is coming first is you generate a set amount of digits and send it over to the other side. Or in this case, we shall have 2 parties, but we can have any number of parties. Then we get back the other set of digits. And once that's set up, we generate the addresses. Both addresses should match. Every time we generate a new transaction, it should be going from one address to a different address made by digits from Yannick, and in this case from Iwa. And once the addresses are constructed, they represent the leaves from the tree that we said before. So once, in this case, Iwa wants to send some to Yannick, what he needs to do is construct an initial serial value bundle. There's no money being changed hands here, but it's the first one to make sure the bundle is set up correctly, and that's why Iwa needs to send the value over, and then Yannick needs to verify the bundle, saying that nothing's wrong. This is where both parties get to agree on what's going on, and then they sign the bundle. Once the bundle is signed, both parties get to see what's the first transaction that sets up the volume and the bundle in this case. And after that, you get to apply the signatures and verify the bundles on the first party. Once that's done, you get both signatures on the bundle, and this bundle can then be attached to a dangle if you want to, or keep going through different transactions. Once this is done, there's no much use of it if we don't keep transacting, because the balance here is the same as the first 2 transactions from the users to the tangle. So this is ready to deposit the agreed amount on each of these transactions in each of these addresses. So making a transaction once the channel is open and set up, you just need to prepare the state of the channel in each party, because something that's really interesting is that you don't send money or you don't send the transaction to the other party, you just let them know that they need to add that transaction to their state of the channel. This is very important because you are not sending the object to the other party. Remember, this is an ad hoc connection between the 2 parties. There could be no internet. This could be a Bluetooth connection. This could be an LP1 connection. It could be Segway or any other way of connectivity off Tangle completely. It could even be written letters if you want to, because this is something that's going on between the parties and the parties only. So in this case, the acceptance of the transaction is done by signing the bundle and returning it with the signature of the party that's interested in that going forward. If the party doesn't want to accept that, they just refuse to sign that, and that's like breaking the transaction. So if all parties agree, they validate each other's signatures, and once that's done, you get to update the channel on each party. Meaning, I have a party, I'm one of the party interested, and he's the other one. Both have the state of the channel in full. 100% of the state lives in every computer, or in every machine, or in every cell phone. There's no way for one to have some of the information. So whenever I want to send something to him, I'll let him know that I'm signing a transaction that's adding them to one of the first leaves of the node that we said on the first tree. And then they update the local state, meaning I'll update my own and he will update his, and that will give us a new state. So if you want to be more visual about it, you can have Iwa propose a transaction to send 100 Iota to Yannick. Then Yannick will agree the transaction, will mutate the bundle by signing it and returning the signature. So once Yannick agrees to accept that money, who wouldn't, right? But anyway, so new bundle plus Yannick signatures will be returned to Iwa, and we'll check and make a diff value, meaning compare it with the actual bundle that started sending, because there will be maybe a man in the middle or someone that's a bad party that wants to change the actual value from the first step. So if there's OK, then you get the EOS signature back to Yannick, and then we have both signatures, and this bundle gets the transaction, and it's ready to be updated again on each side of the channel. And once the transaction is updated on the state, then you can choose to either close the channel or keep transacting. So I'm gonna go over rejecting because it's simple. You just don't sign it, and that's it. This is a simple design. So closing the channel is the last part of all of this. Is the way where you make sure everything is happy with the current state, and this is the time where all of the consensus come to mind, and the settlement is done. Every transaction will take from the initial deposit of each party, and will start transacting that to whoever they want, because at the first time, what I said was each user will give a settlement address or an incoming address where they will get all the transactions to. So at this point of time, every bundle has an input taken from the multi-signature address from all the deposits at the first time. All these deposits are taken from there and then are transacted to wherever they want to be, but always out from the multi-signature address and into one address that can only be controlled by either party. So whenever they accept the state of the current channel, they will be able to attach this bundle to the tangle. And this is where all the magic comes to life, where all these maybe thousands of transactions going on back and forth, and then we only get one closing transaction on tangle, and the confirmation is currently less than a minute, and that's all that's enough for maybe days of transacting between machines. So this is the flowchart of closing a channel. First, you have to take the latest state and spread the remainder across each user. So the party that's wanting or proposing to close the channel will be in charge to transacting what's left on the balance of the channel, of the multi-signature address, and then send it over to the remainder of the settlement addresses. So if you see here, you have the final state with the bundle on the signatures. You get that to Yannick, which in turn will verify that everything's okay, nothing was modified in the way, and then generate the signatures that only that party knows, and that will allow Iota with Yannick's signature to construct the bundle and attach it to the tangle, which is the same way that MAM work, the same way all these regular transactions work. So this is the part where, in this case, there's not that much time. I would love to give you the full demo, but I want to show you a video of an application that's working on the Tangle, but also off Tangle in a way that two browsers, it's a web application, two browsers will be able to open a chat application and transact between each other. But the thing here is they can also send value transactions that live off Tangle. And the way these two browsers are communicating is via WebRTC. So there's no intermediate server. It's just one ad hoc connection to each other. So there's no third party involved on the same demo. So let me just put up the video. I'm just gonna make this faster so it doesn't take that much time, and let's play this. Okay, so this was one of the demos that the foundation gave. So first you would enter to a website, then you would get a different web or a different party. So you would start a channel and give this link to any friend or family that want to test this with. In this case, we're going to use an incognito browser. So we have two different sessions. So on the left, you got one of the sessions. On the right, you have the other one. The right one started the channel, and the one on the left is going to join it. So here it says under channel. So at this point, they are generating deposit address. This is done on Tangle. So you get a transaction from your seed, and you get an amount of tokens assigned to you. This is all done with real tokens at this time. So they are actually transacting real money, though they are just transacting tiny amount of Iota. So that's not, it's negligible. So they want to set up the channel. In this case, they want to set up an amount of Iotas. And they can also send text to each other on the same page. You say, hi, this is screen 1, and there you say, hi, this is screen 2, just to make sure everything's working. Once that's done, you get to send an amount of Iotas. So if you see it's a bit tiny, but you say remaining spendable Iotas just before that, you would say, okay, I want to send 50. And then the other party needs to confirm or reject that transaction. At this point, they are signing with their signature the transaction. And once that's done, they are approving the transaction. This party gets decreased an amount of 50 Iotas. Now it's 950, starting with 1,000. And this party now has 50 Iotas. But if you see, you have the remaining spendable Iotas still at 950. You won't be able to exchange the ones that you have just received. Keep in mind that because it's useful for understanding how this works. So once again, they are saying thank you for giving me Iotas. Who wouldn't? And then a new transaction from left to right with 250 Iotas. At this point, the channel is transacting only 300 Iotas, and the rest is still on the multi-signature address, controlled by both parties. So in any time they want to close the channel, they will still get the 700 divided by 2. For each will be able to get one of those. So one last transaction from right to left of 500. And if you see, the balance still means 300. It doesn't change. It won't subtract from that. It will subtract from the transactable amount. And what you're going to see now is that the last transaction from left to right, once it's accepted, will show the latest state, where there's always an incentive to keep the latest state because of the remaining balance, and not because of your balance, because your balance is always lower than the transactable, and then your balance on the left will only show you 500 Iotas. So they say, okay, I want to close the channel, and once they say, right says, I want to close it, the left says, okay, if this is not consensus, then the channel won't be closed, and the remaining balance will stay on the multi-signature address, meaning that a third party, maybe if this is 2 out of 3 signatures, can help. If not, all the transacting bundle won't be able to be used by anyone until they come back to an agreement. So this was a quick demo of a channel interacting out of the Tangle and just attaching the first transaction and the last transaction. So I would love to give you more in-depth descriptions or in-depth maybe tutorials and stuff. I can help you work on this if you want to set up any proof of concepts, or if you want to build something with Flash channels. I'm open to questions, more technical or less technical, or maybe discussions of use case or future verticals that may be a nice fit for Flash channels, and those that you might want to use Flash channels, but that's not the right case, because most of the questions regarding Flash channels are turned to an answer of you should use MAM or MAM channels, or sorry, MAM messaging, because theirs is not for transacting information, it is just meant for transacting value. You couldn't say, you could not transfer zero value transactions on a flash channel. There's no point on doing that, so it's either counterproductory. So that's not something that you should do. So this is all for today. I would, as I said, I would love to give you more, but we are running out of time. So this was Flash Channels for Iota. So if you get any questions, I think we have time for a few. Yeah.
Inevitable question.
Sure.
I'm finding many resemblances with the Bitcoin Lightning Network, right? Is that right? Am I right about it? Multi-signature, acting like an escrow, transacting off-chain, off the blockchain to speed it up. Am I right in my appreciation? Is that something like the Lightning Network but applying to Iota?
There's a resemblance between, just put it there, give it to me. There's a resemblance between Lightning channels because both do off-network or off-blockchain or off-tangle transactions, but the main difference here is this is done using the economic incentive of not using the whole amount of stake of your network, and you could do this using the feeless feature of Iota that doesn't need to include any fees either for the Lightning Network per se, like the Lightning Network, or even the transactions going in and out of the blockchain. So putting that aside, when you want to start a channel, you can do so free. That's something useful, but this is also that's something you could do from different multi-signatures and set up a channel in a way where you couldn't do that with a Lightning Network because you are presumed to be using the network itself. You could do this without working on the Lightning Network, and you could do this on your own without transacting with other parties. Okay, any other questions? Yeah.
I have a question. Still, it takes to confirm the first transaction, opening a channel.
Yes.
So it means that it takes, for example, at the moment, it's about 2 minutes. Yeah, to confirm. So this use case when the car is coming to the petrol station to fill up, so it still transacts at least 2 minutes, no matter how you then later pay, how fast you are exchanging the value. So it's not practical. I mean, it leads to some pre-opened channels between merchant and the buyer.
Well, the one solution for the opening channel delay is pre-open channels. But the thing here is the current time for confirmation is around 2 minutes, as I said, but it's gonna go lower and lower and lower over time. So these the same thing as MAM channels or MAM transactions, that they need to confirm to be able to be on the tangle. So you would need a bit of time for that to be able to be consumed by other parties. Right now, Iota is a proof of concept in all of it. It's beta software. It's growing in network size. So as long as the network is growing, the confirmation rates are going to go down and down and down over time, and that will help you. And that will help you use this in the future. I'm not saying that you should go and replace petrol stations with flash channels right now. It's just a way for you to do that more efficiently when the network allows you to use sub-minute transactions. And even then, you would be paying with a credit card, and that will take you more than a minute in a normal transaction with using a plastic card, which is going to be replaced by applications where you can use even QR codes and stuff like that. So this is going to be something that machines are most going to be using instead of humans, if you know what I mean. Two machines are going to start to interact with each other, maybe the car with the station, and not you with the man with the owner of the station. So this gives you a way for you to interact with machines to machines, and not something that you would do with your own time. Right now, it's not useful, I know that, but it's going to be. And letting developers start early developing stuff for this or using this as a solution is going to help them get there faster when the network is ready.
Thank you. I just wanted to say that it's more about the streaming of payments than one-time payment, because it doesn't give any advantage of one-time payment between merchant and the buyer who do not know each other in advance.
Well, either if a company that sells energy wants to, you can keep it. If a company that sells energy wants to keep an active channel with every customer, they were going to be needed a lot of stake amount of tokens to be able to do so. So most of the time, the trust is already there. So the consumer is the only one that's staking on the channel, and the company won't stake at all. So it would be 100 stake from the client and 0% stake from the company, because the trust is already there. This works when there's no trust at all, or there's a third party that can settle disputes. Any other questions? All right, cool. Thank you so much. Thank you for staying late.